My name is Mr. Toure, and I welcome you back to another lesson. Today, our lesson on geometry is perpendicular lines. We'll be dealing with perpendicular lines, identifying lines that are perpendicular to each other. Okay. So, our introduction to our lesson here, in real life, we see objects meeting or intersecting at right angles. Objects do meet or they do intercept at a right angle. For example, the sides of a rectangular and square floor tile, they do meet. Okay? They meet at right angles. A rectangular and a square floor tile, they do meet at the right angle. Mortar joints or buildings are designed to either vertical or horizontal, thus meeting at right angle with each other. In this lesson, we are going to learn what perpendicular lines are. In this lesson, we are going to learn what perpendicular lines are, and we'll be giving examples in real life situations, like we did right now in the wall and the tile floor. And some of their basic properties. What will make you understand that this is a perpendicular line or these two lines are perpendicular to each other. Now first, we tell you what are perpendicular lines themselves, their definitions. In geometry, as we know, is a branch of mathematics. Perpendicular lines are defined as two lines that meet or intersect each other at right angle. It is not only two lines that meet, but they must meet at a right angle. Where these two lines meet or intersect, that point must be a right angle. And here, if you say a right angle, we are referring to a 90 degrees angle. Parallel lines are lines that never meet, and perpendicular lines meet at right angles. These two lines are totally different. We say parallel lines are lines that will never meet. No matter how short or long they are, parallel lines will never meet. Unlike perpendicular lines, they do meet at a point, and that point must always be a right angle, that is a 90 degrees angle. Recognize pairs of parallel or perpendicular lines. Perpendicular lines can be found everywhere around us. Everywhere around us, you can find perpendicular lines. So, vocabulary, intersecting lines. What are intersecting lines? When two lines intersect or they cross each other at a point, you call them, these two lines are intersecting lines. These are two or more lines that cross each other at a point. Okay? And that point is called their point of intersection. Here we have two lines. We have line PQ and line SR. PQ and line SR, as you can see, they cross each other or they intercept at point O. So this point here is the point of intersection. PQ and RS intersect at point O. Therefore, point O is common to both lines. And we can also say point O is their point of intersection, because that is where they meet. Point O is the point of intersection because that point is where line PQ and line RS intersect. Now, two rays, line segments or lines, are perpendicular to each other if they intersect or meet at a right angle. As we can see in the diagram here, we have line PQ, as you can see, and then we have another line SR. And as you can see, they intercept at a point R here, where they meet, and that point happens to be a right angle. So therefore, we can say PQ is perpendicular to SR. Why are they perpendicular? One of the properties of a perpendicular lines are they meet at a right angle. Okay? The small square here indicates that this is a right angle. Their point of intersection is at a right angle. So we conclude that PQ is perpendicular to RS. And we can write it as PQ with a line on top is perpendicular to line segment RS. PQ is perpendicular to RS. Properties of perpendicular lines. Now we shall talk about the properties of perpendicular lines. This will easily help us to identify whether these two lines are perpendicular to each other or not. The first property said they intersect or meet each other at 90 degrees. Perpendicular lines intercept or meet each other at 90 degrees. And the second property says if two lines intersect at 90 degrees, two lines, they intersect at 90 degrees, they form four right angles at the point of intersection. Now you are talking about two lines that cross each other, okay, and four 90 degrees are formed, okay. There's an example here which says identify whether the pairs of intersecting lines below are perpendicular or not. Let us identify. Bearing in mind the properties that we've read before, A, we have two lines. Are these two lines perpendicular to each other? Remember, their point of intersection must be 90 degrees must be formed there. And it reads if two lines intersect, they will form four 90 degrees. Looking at A and diagram B as well, we have another two diagrams, C and D. As you can see, B, the two lines are perpendicular because they meet at a right angle. So therefore, all the other angles are 90 degrees. So we have four 90 degrees here in B. C also, this is a 90 degrees, which tells us that the other two triangles are also 90 degrees. But look at D, all we can see is two parallel lines. These two lines can travel side by side and they shall never meet, okay? So therefore, we can say B and C are perpendicular lines. They are examples of two lines that meet at a right angle, so therefore perpendicular to each other, and C also, the two lines are perpendicular to each other. Now the solution says A, diagram A, as we can see here, not perpendicular because they do not intercept at 90 degrees. As we can see, their point of interception is not 90 degrees. The two opposite angles are wider than the other two angles. The other two angles that are facing vertical opposite, okay? And then B, it says perpendicular because they intersect at 90 degrees. Let's get back to example B. As we said before, they are perpendicular because they intercept at a right angle. We still move on. It says diagram C is perpendicular. As we said before, this is perpendicular because this is a right angle here, and obviously all the other angles are 90 degrees. And the last one there, it says is D is not perpendicular. The two lines at D are not perpendicular to each other because there's no point at which they touch each other. Now here is another example. Considering the cube below, identify any four pairs of perpendicular line segments. Any four pairs of perpendicular line segments. Four lines that are perpendicular to each other. As we can see, AB is perpendicular to AH, okay? And as we can see here, BG is also perpendicular to EG, and FC is also perpendicular to BC, okay? There's a bunch of lines that are perpendicular to each other, and then all of them are stated here. These are amongst the perpendicular line segments in the cube. AB and BC are perpendicular. AB and AD are perpendicular. AB and AD are perpendicular because they form a right angle here. AB and AH are also perpendicular. As we said before, AB and AH are also perpendicular lines. AB and BG are also perpendicular. AB and BG are perpendicular. We said all this before. So as you can see, there are a bunch of line segments that are perpendicular to each other. Consider the cube below. Are EH and CD perpendicular? EH and CD, are they perpendicular? Let's have a good look on a cube here. Okay. So the question says, is EB, EF, line EF, is it perpendicular to line CD? EF and CD. As you can see, they are not perpendicular, they didn't meet, and therefore they didn't form a right angle. Because before you form a right angle, there must be a point of intersection. Now there is no point of intersection, talk less of forming a 90 degrees. Okay? We move on to the next slide. Name a line segment. You can hide this. Name a line that is perpendicular to line EF. We have our diagram here, and line EF is from here to here. As you can see, EF. And is there any other line that is perpendicular to line EF? Obviously, we see EG is perpendicular, and as we can see, FG is also perpendicular. Okay? Option A says line AB, AB here, okay, which is not perpendicular. Line FH, if H here is there, is HF, is that perpendicular to line EF? No, because they did not have any point of intersection. Line BC, line BC doesn't have any indication that they are perpendicular because they did not touch each other. Okay? The ones that are perpendicular is line EF. It's perpendicular because they have a point of intersection, and line EG also is also perpendicular to the line EF. And then here we have a question. Intersecting lines are thus perpendicular. Intersecting lines, A says always perpendicular, B reads sometimes perpendicular, and C says never perpendicular. Intersecting lines are sometimes perpendicular. They can intersect without forming a 90 degrees at their point of intersection, and these two lines are still intersecting lines, but they are not perpendicular. In order for them to be perpendicular, they must form a right angle at the point of intersection. Question 4 says, a line can be perpendicular and parallel at the same time. A says always, B says sometimes, and C says never. The correct answer here is never. Perpendicular lines and parallel lines. Lines cannot be perpendicular and parallel at the same time. Remember, the properties of parallel lines is they shall never meet. And perpendicular lines must meet at a point, and that point must be a right angle. So therefore, lines cannot be parallel to each other and at the same time perpendicular. That is never. A perpendicular line is drawn to a line segment, MN, and N using a protractor and a point at a point P is marked on it. Which of the following is true? You have two lines. You have a line let's say this is line M and this is N here. Okay? And There's another perpendicular line here. There's a line perpendicular to this, and we call this P. Okay? Which of the following is true? Which of the following is true? The options we have here are, our options are MP is perpendicular to NP, MP is perpendicular to NP. As you can see, M and P have no direct connections here. It's just this line here. And then we have MN, line MN is perpendicular to line MP, which has no connection as well. Let's move on to the other options. The last option, sorry, C says M is perpendicular to P, and the last one reads MN, which is a line segment here, is perpendicular to NP. They meet at a right angle here. So therefore, the correct option here is option D, because MN is perpendicular to NP or PN. Question 5 says two lines thus meet at more than one point. Two lines meet at more than one point. A says always, B says sometimes, and C says never. Two lines meet at only one point. Two lines cannot meet at this point and continue to meet at another point. They always meet at one point. So to say that, to make this statement correct, two lines never meet at more than one point, because they always meet at one point. Two lines shall always meet at one point, not more than one point. Question 7, are these two lines perpendicular to each other? Are these two lines perpendicular to each other? We would conclude that these two lines are not perpendicular to each other. Is a no question, no is the answer, because they do not intercept at a right angle. So these two lines are not perpendicular to each other. That ends the lesson here. I thank you so much for your kind attention. See you next time.